just a little clarification over some problems.
Okay. What do you got? Can you verbalize it?
Yeah.
Okay.
So I'll probably do one from each unit.
I'm sorry, what?
I'll probably do one from each unit we have. We just have
Yeah, whatever you think best.
Okay. So the first problem, it says you should get two solutions. What is the sum of these two solutions? And the equation was x squared minus 13x plus 40 equals 0. And would you just do the common, or the square, whatever, like just factor it and then?
There you go. You hit on it.
Oh,
factor it.
That's it. Okay.
In other words, here's the problem. When you have the sum and difference of stuff equal to 0, you can't solve it. But if I have the product, if I have two things multiplying together equaling 0, it allows me to solve it. Because the only way you can multiply two things together and get 0 is if one of them is 0. So if I can factor this, I will have two things multiplied together. So how does this factor? Go through the steps of factoring with me.
So it'd be x and x in both those. And then, well, I mean, we do the little diamond method, like what?
I don't care. I don't care how you do it. If you're really comfortable doing that method, go ahead. If you get the answer, fine. If you can't get the answer with that method, then I'm going to show you my method.
All right. What multiplies to 40 and adds to negative 13? Negative 5 and negative 8.
Good. Okay, now what does that tell you about the solution? What is x equal to?
Would one solution be positive 8 or would it be negative 8?
No, what we're going to do is we're going to take each of these. I'm going to set that equal to 0 and solve it, and I'm going to set that equal to 0 and solve it.
Oh, so yeah, x equals 5 and x equals 8.
Exactly.
All right. And then the sum of those would just be
now,
13.
That's correct. Now, be a little careful. It's not always the opposite of this number.
Yeah.
In other words, if one of these solutions was that, then the solution is not plus 5, it's 5 halves. In other words, I would set 2x minus 5 equal to 0, and when I solve that, I get 5 halves. So it's only the opposite of this number if the coefficient is 1 on that.
All right.
Okay.
Yeah, that was much easier than I thought it to be.
Yeah, these are what I call first-order factoring problems. Generally, you can use 3 or 4 steps here, or your diamond method works fine. I have my personal preferences. With math, there's usually more than one way to go. In other words, almost every problem can be solved in a different manner to come up with the same solution. What else you got?
So I'm just going to do one more problem from that unit.
Okay.
It says write the expression as a complex number in standard form.
Okay.
And it's 1 minus 2i over 3 minus 5i.
How'd I know you were going to do division?
I don't know.
That's the only hard one. In other words, if I'm adding complex numbers, piece of cake. Or subtracting, piece of cake. Or multiplying, you just FOIL them.
Yeah.
But division is a different story.
Well, like, what's the...
really,
I know how to do it, but I don't know the first step. Like, is it just you multiply by the other side?
Okay. What I'm trying to do is make the denominator real. That's my goal. In other words, math does not like imaginary numbers in denominators. So you have to make the denominator real. Well, the way to make it real is to multiply it by the conjugate of that. 3 plus 5i. Okay? That's
So you multiply the top.
going to guarantee my denominator becomes real. Now, I can't multiply the bottom by that unless I also multiply the top, because my only constraint is I can multiply this thing by the number 1 only. If I multiply it by any number other than 1, I'm changing its value. But if I multiply it by 1, I don't change anything at all.
Uh-huh.
Foil the bottom and tell me what you get. Notice, first of all, that's difference of perfect squares factored already. So to put it back together again should be super quick.
It'd be 9 minus 25i.
You got it. No, minus 25i squared.
Squared. Yes.
Right?
Yeah.
Okay. In other words, if I gave you this as a problem, you'd take the square root of that minus the square root of that plus or times the square root of that plus the square root of that. So it's pretty useful when you recognize difference of perfect squares already factored, because it does make it faster to put it back together again. So 9 minus 25i squared, the key is knowing what I squared is.
Isn't it 1?
It's negative 1.
Negative 1.
Here.
Yeah.
I is equal to the square root of negative 1.
So then it'd be 9.
I squared equals negative 1.
So would it be...
One of the most important things to remember. That's the only thing you really have to know about imaginary numbers, is that I squared is equal to negative 1. Because every time we get I squared, we're going to change it to a real number.
Yeah.
So what's the denominator become?
Would it be 34?
Uh-huh. And now we've made it real. Now, the numerator is going to remain a complex number, but that's okay. Numerators can be complex numbers. It's just denominators cannot be. Okay, foil these two. Tell me what you get.
3 minus 10i squared, possibly? Would it be squared or no?
Well, first of all, hold on a moment. This, when I say foil, you know what that means?
Yeah.
Okay. So I'm going to multiply the first terms, then I'm going to multiply the outside terms, then I'm going to multiply the inside terms, the I of foil, and then I'm going to multiply the last terms. But basically what I'm doing is starting with the left expression, left to right, and take this 1, multiply it by each of these terms, and then go back and take that and multiply it by each of those terms.
So would it be 3 minus...
Rather than foil, I prefer ET, every term by every term. And do it systematically. Do it so you can't possibly forget, because you might be multiplying 4 terms by 4 terms. And then it gets complicated and you have to really keep track of it.
Would it be 3 minus 11i?
No. Let's do it term by term. Before we try to combine it, let's do it term by term. So what's the next term after 3?
Negative 6i.
Hold on. I'm multiplying that by that, and then I'm going to multiply that by that. What is that term, the second line?
5i.
Plus 5i. Now, what's this term times that?
Minus 6i.
Okay. And finally?
Minus 10i.
It's minus 10i squared. You see why it has to be squared?
Yeah.
Okay. Now we need to simplify that numerator. Well, we can combine that and that. What does it equal?
Which ones?
The far left and the far right of the numerator.
Would that be 13?
Uh-huh. So we'll
13.
write 13, and then combine your i's. What do you get?
I. Negative I.
Negative I. And it's all divided by 34. So there's your answer. The only problem is that answer is not in this format, a plus bi. Okay? Most likely, I mean, I don't know what kind of test you're taking, if it's going to be multiple choice or whether you're going to have to. Yes?
Yeah.
Well, then you probably don't have to know this distinction. But this is not an a plus bi format. What would I have to do to make it in that?
I don't add 2i.
No, separate it into two fractions. In other words, I can separate into the real part right there, and then I can separate it into the imaginary part. That's what that means, is that I have the real part and the imaginary part. Well, the real part becomes 13 over 34. The imaginary part becomes 1 over 34 times I. And so if I wanted my answer in standard format, that would be the correct answer. You know, on your multiple choice test, they may give you this or they may give you this. I don't know. They would give you one of these two. But there is that subtle distinction between, you know, this answer and putting it in standard format like that. Because if you want to graph this answer, you kind of have to put it in standard format to graph it. Because the graph, I don't know if you've talked about graphing, but that's the real axis, that's the imaginary axis. So whatever A is goes here, whatever the number B is goes there. So that's how you graph a complex number.
All right.
What else?
Let me see the third unit. Okay.
How come they canceled school today? I was really shocked with finals and everything.
Yeah, well, our finals start tomorrow and Thursday.
Okay.
So, I mean, this works out really well for me.
Well, maybe I'm wondering if that isn't one reason they did it, was to give people a chance to just study for their finals. But I do have a student that's their finals start today.
Really?
Yeah, geometry student. It's split into two. She takes part one today and well, not today, obviously, because they canceled school. But
yeah, I wonder what they do about that.
I don't know. I'm curious myself. Because it's not, I mean, we've got snow outside, but it's not that bad. I wouldn't think that this snow would normally cancel school. But I'm sure there were thousands of relieved students today. Right?
Yeah.
I imagine you were one of them, because it gives you time to study for your finals.
Yeah, and I had like a basketball game that was super far today tonight.
Uh-huh.
So after school, we'd have to leave right for it, and then I'd get home at like 10:30.
Is the game still going to go on tonight?
No.
Oh, okay. I was going to say, I would think that would get canceled.
Yeah, it did. So these problems, it says write an equation of a polynomial function that has three turning points in an end behavior that is up and up.
Your audio's breaking up a little bit. Find a function for the polynomial function. That's as much as I heard.
That has three turning points in an end behavior of up and up.
Okay. End behavior up and up.
So the first problem is 4 over 9x plus 6 over 27x. Is this what we worked on last week?
Well, I didn't hear the entire problem.
No, that's it.
But what did they want? The back part I couldn't hear each time.
So it said write an equation of a polynomial function that has three turning points.
That has three what?
Turning points.
Okay. what they're talking about is this. If it has 3 turning points, there's one turning point, there's another turning point. If it has n behavior of up and up, then the function has to look like this. There's one turning point, there's 2 turning points, there's 3 turning points.
Yeah.
Like that. So that would give you the up and up behavior. And what does this have to do with anything?
That's the problem. Oh, wait. Oh, totally different question.
Okay. That's why I was confused, I think.
All right. Erase the end behavior and such.
Okay.
We're supposed to simplify that fraction.
Okay. How do we add these 2 fractions?
Don't we find the common denominator?
Yes. What is it?
Would you just multiply 9 by 3?
Yeah. In other words, with variables, frequently you end up multiplying this denominator by this denominator to find a common denominator. But in this case, you don't need to do that. Mm-hmm. This is already the common denominator. In other words, we've got it. The only thing you need to know about a common denominator is each denominator evenly divisible into it? Well, 27x is certainly divisible by itself, and it's also divisible by 9x. It equals 3.
Yeah.
So it's the common denominator. And this is the way I kind of like to do these problems. Figure out your common denominator and then write it like that, and then fill in the numerators. What's the numerator over here going to be?
What do you do with it? Do you multiply by 3 also or no?
Well, what you do is divide that into your common denominator, take your answer and multiply it by your numerator.
So, wait, what?
Divide this into the common denominator.
So to divide that by 27?
No, the other way around.
Divide 27 by that.
Uh-huh.
So then 4 times 3? So
yeah,
that'd be 12.
That's 12. And the key here, and this is very, very important, always be checking. Make sure that you have not changed the value of that fraction. Are those 2 things the same thing that I've circled?
Yeah.
Then you've done it correctly. And that's what's important. I don't care how you do it. You can use any method you want. Just make sure that you do not change the value of the expression.
So would 6 over 27 still be 6 over 27?
Yes. And now you can add the 2 together because they have a common denominator.
So it would just be 18 over 27?
Can't throw away the x. The x comes along.
Yeah, that's what I meant.
However, there is a simplification that can be done.
Can divide by 3, so it could be 6 over...
Hold on, let me give you a little clue. This is going to prove helpful in a lot of situations. A number is divisible by 9 if its digits add up to 9.
Oh.
Notice that all the multiples of 9, the digits add up to 9.
I never noticed that. Wow, that's
well, it's actually a really neat thing. And it works for big numbers. If I want to know, if I give you a really big number like 10008, and I say, is that divisible by 9? Yes, it is. The digits add up to 9. Okay? So, when you spot something like this...
Does that only work for 9?
Yes, unfortunately. But it's a great tool for the 9s tables. So, these digits add up to 9, so do this. That means both top and bottom are divisible by 9. So what does that simplify to?
6 over 9x.
No. In other words, divide top and bottom by 9, not 3.
2 over 3.
2 over 3x. And notice that is not the same as 2/3 x. The x is in the denominator, clearly.
Yeah.
If it was 2x over 3, that would be the same as 2/3 x. But you got to leave the x in the denominator. Okay, so that's our answer. Okay.
What else? Well, I've slowly gotten how to do this. Oh, I know what to do. So it's more the a n equals a squared. Yeah, those things.
A
Like,
sub n.
like the explicit and recursive and all that.
Okay. So okay, go ahead and give me the problem.
It says write the first 5 terms of the arithmetic sequences. So it says an equals -2 plus 8n.
Okay, how are we going to write the first 5 terms of that?
I don't know.
Well, n counts up. N is a counter. It starts with 1, and then it goes 2, 3, 4, 5, 6, 7, 8. So the first term, a sub 1, plug in 1 for n.
Oh, so that's all you do, and then you do it.
It's that easy.
That's all you do for everything.
That's all you do. Your sound keeps going away. I don't know.
It might just be because I'm kind of far from the computer.
That's a factor for sure. You want to be as close to your microphone as you can get.
All right, and how do you know if the equation is arithmetic or not?
It's arithmetic if every term is separated by the same amount.
Okay, yeah, that's what I thought.
This sequence here, every term is separated by 3.
Yeah, that's what I thought it was. I just wanted to clarify.
Have you studied geometric also?
I don't think so.
Geometric is where every term is a multiple of the previous term. So I'm going to multiply the previous term by 2 every time. That is a geometric series.
Yeah, I think we've learned that.
You have covered that?
Yeah.
Okay. Well, those are the main 2 series that you're going to cover, are arithmetic and geometric. So the most important thing for you to know is what the general formula of each is. But first of all, let's work our way through this problem. This is a very easy problem. What's the second term?
Equals -2 plus 8 times 2. So -2 plus 16. So would it be 14?
What's the third term?
Times 3 minus 2. 22?
That's the way you do it.
Okay.
And they wanted the first 5 terms. That's all.
Wow, that was easy. So you just do that with everyone no matter what equation they give you?
Well,
no,
they're going to throw these problems at you in different ways.
I'm saying if it's like an equals 7 minus 3n.
For sure that you need to memorize. That is the general formula for an arithmetic sequence. The ones that are separated by a constant.
What's the difference between the explicit and recursive?
This is the explicit. The recursive is always defined as a function of the previous term, n minus 1. Well, for an arithmetic sequence, it's n minus 1 plus the common difference. So this is going to be your recursive. Okay? It depends on whether you know the previous term. In other words, if I gave you this sequence, now here, let me give you the same sequence. What did I give you? I gave you 4, 7, 13, 16, 19. Okay? If I know the first term and I know the common difference, which is 3, then I'm going to use this. That'll tell me the 100th term. The 100th term would be the first term, 4, plus the common difference, 3, times 100 minus 1. That's going to be my 100th term. But let's say I didn't know the first term. Let's say they said, what is the 100th term? Or I'll take this example. What is the 5th term if you know the 4th term? In other words, a sub 5 is going to be equal to a sub 4, that's the term right before it, plus the common difference. Is that true? Well, 19 is a sub 5, that's my 5th term. Is that equal to 6 plus 3? Yes, it is.
Why are you doing the 5th and 4th terms?
Just to illustrate what the recursive thing means. In other words, you're only going to have a recursive formula if you know the second to last term.
Okay.
Well, I was working with the 5th term and the 4th term. So you don't always know the second to last term. So It's not very often that the recursive comes up.
All right.
And with arithmetic differences, it's really easy. If you think about it, the nth term has to be the previous to nth term plus whatever common difference there is. So that's why you almost never get this in a problem. What they're going to give you is find the 23rd term if the 26th term is 15. And there's a common difference of 3. In other words, you're almost always going to be dealing with that. Notice there's 4 variables. There's 1, 2,
what does the
3,
D and N stand
4.
for?
I'm sorry, what?
What does the D and N stand for in the explicit?
The common difference between each term. And
so the difference is the D and the N.
The common difference is plus 3.
All right, and where would you put that? Where D is?
Right there.
And then you plug in the term you're trying to find into N.
All right, so let's take this sequence and come up with the specific arithmetic sequence for it.
Mm-hmm.
Okay? In other words, when I say, this is the general, okay? If I want to come up with the specific for that sequence, then I'm going to start a sub n. What's a sub 1?
4.
What's d?
3.
Times n minus 1. Okay? Now, let me erase this because
And n is just the term you're trying to find. Like if they're asking to see the 24th.
However, I'm not done here. I got to simplify this. Keep going.
Wouldn't it be a sub n equals 7 times n minus 1?
Well, it's plus 3n minus 3.
Oh, yeah, you got to
3 has
distribute.
to be distributed, so it's 1 plus 3n. That's going to be the explicit, specific formula for that sequence only. The sequence that started there and went up by 3 with every term. And that goes on forever. So if I wanted to find the 12,000th number in that sequence, n is 12,000. Plug it in and you get the result.
All right.
Okay?
Wow.
This is the explicit. Make sure you memorize that. You're not going to be able to do any of those problems unless you have that memorized.
All right.
Just know that the recursive is the previous term plus the common difference. Now, the recursive is a little different with geometric sequences. Everything is different with geometric sequences. That is only the general formula for an arithmetic sequence. So, should we cover the geometric?
I don't think we didn't have any geometric ones on the review.
Okay, let me just, it's R times, excuse me, the nth term is r times the first term to the n minus 1, I think. I don't know. I might have to look that up. But if it's not going to be on your test, let's not confuse you with it.
All right.
So arithmetic only applies to sequences that have the same difference between every number. All right, Michael, is there anything else you wanted to cover today?
No, that clarified basically everything I needed.
Good, good. Well, enjoy the rest of your snow day, and good luck on your final.
Yeah, thank you. Thank you for the help.
Okay, Michael. Bye-bye.
See ya.